Hello everyone. Today we are covering section 1.2, trigonometric functions and unit circle approach. We're going to start with drawing unit circle. What is a unit circle? Well, remember from the previous section, it's just a circle, 1 unit radius. My circle probably not perfect. What is 1 unit? 1 unit can be 1 centimeter, 1 millimeter, 1 meter. Just important to have it 1 unit. Imagine that we do have a point on this circle, like point P, which has coordinates x and y, sits on the circle. So we can make a kind of a triangle. One side is going to be x-axis, one side is going to be the line between origin and point P, and third side is going to be a curve arc between this intersection of the circle with x-axis and point P. What is going to be arc length of this arc? Well, if we set up angle theta over here, we remember the formula that arc length equals r theta. Because our circle has a radius equals to 1, it's going to be 1 theta, or it's just going to be theta. So, interesting that if we have a unit circle, we can use arc length of a unit circle to measure angles. And that's just not going to be in degrees, but it's going to be in radians, but it's going to be a number. Just a real number like 1 or 2 or 0.5. For example, our theta equals pi over 3. Well, what is going to be then arc length as? Well, it's also going to be pi over 3. And if you want to calculate it with your calculator, just put 3.14 and lots of other digits, divide over 3, and you are going to get something like 1, 0.4, and some other digits. But this number is just a real number. It's measured in the same units you are using for building a circle. If a circle in centimeters, that's going to be 1 centimeter, 0.4. Okay, so what we are going to do, guys, we are going to define 6 trigonometric functions of this number. And because it's a definition, that's just like people invented a sign for each of these 6 functions, and they invented a rule. So we're going to start with sine of theta. Sine of theta is going to be just y. So sine of theta, it's a name of a function. Y, it's a rule by which we calculate the value of a function if somebody gives us angle theta. So we take the point P, check y, and place it instead of sine. Now cosine of theta is going to be x, and then we are going to have tangent of theta, which is going to be y over x, and cofunctions. Cofunctions are going to be cotangent of theta, which is x over y, and reciprocal functions. For example, function secant, which is going to be 1 over x, and function cosecant, which is going to be 1 over y. If you compare these 6 functions to each other, first you have sine and cosine, they're called cofunctions. Tangent and cotangent, secant and cosecant. Second, we're going to see that, for example, sine is y and cosecant is 1 over y, so they're kind of reciprocal of each other. These two are reciprocal too, and these two are reciprocal too. Well, nice symmetrical set of functions, right? Let's consider example. So I'll consider, for example, point P with coordinates 1 over square root of 2 and 1 over square root of 2. Strange point, let's first check if it sits on unit circle. Is it on unit circle? How to check? Well, you remember that the equation of a circle is x squared plus y squared equals radius squared. In our case, that's going to be x squared plus y squared equals 1, because radius is equal to 1, right? This is not just any arbitrary circle. This is circle centered at origin. Let's plug in x and y here into the equation and check if we get true statement. If it is, means that it's the point sits on unit circle. So 1 over square root of 2 squared plus 1 over square root of 2 squared, is it equal to 1? Well, it's very easy to calculate the square root of 2 squared. It's 1 over 2, right? Plus 1 over 2 equals to 1. Of course, 2 halves equals 1, so it checks. Let me move a little bit up. Now, let's calculate 6 functions of this point, which sits on a unit circle. I'm going to make them in the same order. So I'm going to do sine, cosine, tangent, and then secant, cosecant, secant, and cotangent. So let's start with sine. So sine of theta equals y. What is y of my point? Y is over here. I'm going to label it y, and this is x. So I'm just going to copy it. And then cosine is just x, which is kind of the same, right? I'm using the similar coordinates. Tangent is going to be 1 over square root of 2 divided over 1 over square root of 2. Well, representing it as a product of two fractions, we are going to just get 1, right? Now cosecant of theta is going to be 1 over y. Everyone remembers that division by the fraction is multiplication by reciprocal, which is going to give us square root of 2. We're going to have same result for secant just because 1 over x is going to give us same square root of 2. And for cotangent, we are going to divide the same 1 over square root of 2 over 1 over square root of 2. 1 over square root of 2 divided over 1 over square root of 2, which is going to give us 1 again. Why does it happen? Because x and y here are same, but it's not always going to be the point. Now the question is, interesting. What this point is graphically on circle, like where it sits, what is the angle? Well, if you look at these two coordinates, you're going to see that x equals to y, means that the point sits on the line x equals y or y equals x, which is actually what? Line of 45 degrees. So I'm going to draw the circle again, not necessary, but just to show you. If you draw a line x equals y or y equals x, and this is a unit circle, that's going to be our point P, and the angle over here is going to be 45 degrees, or if you convert it in radians, it's going to be pi over 4. Well, we just got our first angle and first 6 functions. Let's move further. Maybe before we move, I'll summarize this. I'm going to keep only 3 functions from over here. This one's easy to obtain, so I'm going to write down that sine of pi over 4 equals 1 over square root of 2. Cosine of pi over 4 equals 1 over square root of 2. And tangent of pi over 4 equals 1. We're going to start making a little table of known values for sine, cosine, and tangent. These are going to be the first values for the table. I'm going to box them. So eventually I'll ask you to memorize these numbers, but not right now. Okay, let me move it down. Oh, let's say up. So what also we want to know about the 6 functions? Well, these 6 functions are going to have interesting values at points where a circle intersects x and y axis, like here, 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 and here. There are 4 points, right? So what we are going to do, we are going to calculate first 3 functions, sine, cosine, and tangent for these 4 points. I'm going to start drawing a table, and the angles are called quadrantal angles. So quadrantal angles are like intersection with x, y axis. Well, first, let's label what are the angles and what are the coordinates. For example, this one, obviously theta equals 0, right? And the coordinates are x coordinate is 1, right? Because it sits on x-axis, and y coordinate is 0. Next one is going to be theta equals, well, this one is pi over 2, right? Or 90 degrees. And here, x is 0, right? And y is equal to 1. So 0, 1. Next one is pi, and that's going to be this point, right? The pi, angle pi. And the point is going to have x equals -1, y equals 0. And the last one is theta equals 3 pi over 2. It's like pi plus pi over 2, 3 pi over 2. The point is going to have coordinates. X coordinate is 0, right? X is 0, and y is going to be -1. 0, -1. Knowing coordinates is making very easy filling the table. I'm going to place table here. For the table, maybe you guys can start memorizing it too. I'll try to make it as pretty as possible. So angle theta here. And I'm going to put sine of theta here, cosine of theta here, and tangent of theta here. Well, again, you can make all 6 functions into a table, just like I don't have space here. We're going to start with 0, pi over 2, pi, and 3 pi over 2. So that's going to be the end of my table. Well, let's see what we have. Well, first, very easy to fill in vertical, like sine. It's equal to y, right? What is y here? For 0, y is 0. For pi over 2, y is 1. For pi, y is 0 again. And for 3 pi over 2 is -1. For cosine, remember that cosine of theta is equal to x. So we're just going to look at x coordinate of all 4 points, which is 1 over here, 0 here, -1 over here, and 0 again. For tangent, it's a little bit more complicated. We'll need to divide, actually. Let's look over here. Divide y over x. And sometimes it's easy, sometimes it's not. Like, for example, here, y is equal to 0. You divide it over, like, 0. You divide over 1. You're going to just get 0. Easy, right? For the second point, it's not that easy because we are going to have 1 divided over 0. Why? Well, we cannot divide over 0, so we are going to call it undefined. This one, we have 0 divided over -1, which is going to be 0. 0 divided by anything is 0. And the last one is going to be, again, -1 divided over 0, undefined. So very nice table for special angles, quadrantal angles. Okay. So we already know many functions for many different angles, right? We know what is happening with pi over 4, what happens to 0, pi over 2, pi, and 3 pi over 2. Well, we are going to do few more. We're going to move to angles pi over 6 and pi over 3. Move my page, go back to the top. So, 2 special angles we are going to investigate right now are pi over 6 and pi over 3. And by the way, conversion to degrees is going to be what? 30 degrees and 60 degrees, right? We remember from previous class. So how are we going to calculate values for these angles? First, we'll need to know positions, right? If you don't know the coordinates of the point, how do you find the functions? Functions are defined through the coordinates. We need to know the coordinates. Well, that's going to be our first goal, to find the coordinates. To do this, I'm going to start with equilateral triangle, which is going to have angle of 60 degrees at every vertex. Remember that for equilateral triangles, all sides are equal, right? And because the sum of the angles is 180 degrees, and we have 3 same angles, from where we can get the theta, the angle is 180 degrees divided over 3, which is going to give us 60 degrees. So all angles are equal and 60 degrees each. Well, we already have our 60 degrees somewhere in this triangle, right? So it's pi over 3. We'll need to get the angle of 30 degrees. How do we get it? We are going to divide our triangle into sub-triangles by doing the perpendicular line from top vertex to the base, the height. So let's consider now just like this triangle, just half. I'm going to graph it separately. and talk a little bit about the sides. Imagine that we set up this side equals to 1. What do you think is going to be this side, the bottom one? Well, the bottom, the whole side is also equal to 1, right? But if we divide it by 2, which happens because height in equilateral triangle is the same as median, we are going to have 1/2 over here. So we know two sides of this triangle. We also know that this angle is a right angle, and we can use Pythagorean theorem. We're going to have 60 degrees angle here and 30 degrees angle here, right? 60 plus 30 is 90, so this one's supposed to be 90 to give us 180. For Pythagorean theorem, what are we going to have? Hypotenuse, in our case this one, equals to 1, right? 1 squared equals 2 square of this side plus square of this side. This side is unknown. Let's label it x. So we're going to put x squared. And this side is known, which is 1/2, and we're supposed to square it too. Well, I'm just going to copy everything squared besides x because I don't know x. And we can calculate x just solving equation. It's 1 minus 1 over 4 equals x squared, or 3 over 4 equals x squared, from where x equals plus minus square root of 3 over 4. Well, because we are dealing with length, which is like obviously positive value, there is no negative numbers on the ruler, we're going to choose a positive value, and the square root of 4 is going to give us 2. So we do have square root of 3 over 2. So that's all the signs. Now, how are we going to apply it? Let's now draw a unit circle and try to see how to use it with this triangle. I'm going to start with angle of 30 degrees, something like this. That's angle of 30 degrees. Let me label it here. So I know that hypotenuse equals to 1 because it's a unit circle, right? Hypotenuse. Angle of 30 degrees, and the adjacent side to this angle is square root of 3 over 2. So, well, kind of hard to label, but this side is a square root of 3 over 2, which is going to give me x coordinate of my point, because it's x coordinate, right? Y coordinate of my point is going to be what? 1/2. It's kind of opposite side of this angle. Opposite side of 30 degrees is 1/2. Well, I'm just going to put it 1/2. Now, I'm ready to write down the 3 functions. I'm not going to do all 6. I'll do just 3, okay? So I'm going to start sine of 30 degrees equals y, right? In our case, y is 1/2. Cosine of 30 degrees equals x. In our case, it's a square root of 3 over 2. This is x. This is y, right? And tangent of 30 degrees equals y over x, which is 1/2 over square root of 3 over 2, which is 1/2 multiplied by 2 over square root of 3. 2's cancel, and we are going to have 1 over square root of 3. Well, you can calculate the rest of them by just like making reciprocals. Okay, so we're done with our 30 degrees angle. Now we're going to move to 60 degrees angle. I'll need to repeat the triangle. Here I'm going to label, this is 30 degrees, 30 degrees. Now we're going to repeat the picture with a circle, just a different angle. The circles are not super nice, but if this is 60 degrees, we're going to look at this triangle back. Across 60 degrees, we have side equals square root of 3 over 2. So this side, square root of 3 over 2, which is going to produce y coordinate actually here, right? Well, adjacent to 60 degrees is 1/2, 1/2. And that's going to be x coordinate. Now, ready to write down the function. Sine of 60 degrees is x, 1/2. Cosine of 60 degrees is y, square root of 3 over 2. And tangent of 60 degrees is y over x, square root of 3 over 2 over 1 over 2, which is a square root of 3 over 2 by 2 over 1, which is going to give us square root of 3. Very nice. So we got one more set of numbers. Now, guys, I'm going to draw a table, which is a combination of all numbers we learned already. And I'm going to accumulate everything in this table. You will need to start memorizing this table, and maybe like in a couple of weeks, you are going to remember it. so you can use it without looking up in a table. I'm going to check it in quizzes, but mostly I rely on you to memorize a table. So I'm going to build a table. I'm going to call it the table. I'm going to make it bigger. So we'll start with theta here. That's going to be sine of theta, cosine of theta, and tangent of theta. Here I'm going to have 0. Here pi over 6. Here pi over 4. This is 30 degrees, 45, and next one is 60, which is pi over 3. Now I'm going to be pi over 2, which is 90 degrees. And I'm going to put 2 more, pi, and 3 pi over 2. Well, just to make a reference for numbers and degrees, 0 degrees, 30 degrees, 45 degrees, 60, 90, 180, and what is 270, I think, right? Okay, just like same values in degrees. Well, let's first fill in 0, pi over 2, and I'm going to just, I don't know how to put the, okay, I'm going to put it like this. I want to show you the second table too at the same time. So I'm going to use this little table and fill in 0, pi over 2, pi, and 3 pi over 2. So for 0, I have 0, 1, 0, 0, 1, 0. For pi over 2, I have 1, 0, undefined. Pi over 2, 1, 0, undefined. For pi, 0 minus 1, 0. 0 minus 1, 0. And for 3 pi over 2, minus 1, 0, undefined. Minus 1, 0, undefined. Only just to fill this one. For this one, I'm going to use the values we calculated after, right? For pi over 6, if you go back, it's 1/2. For cosine, square root of 3 over 2. And for tangent, 1 over square root of 3. That's what we did with triangle of 30 degrees, right? I'm going to calculate these ones, not calculate, fill in these ones, and then fill in this. Well, for pi over 3, square root of 3 over 2. For cosine is 1/2. You see they're kind of crisscross equal. And tangent is just 1 over, just square root of 3. Opposite of 1 over square root of 3. And for pi over 4, everything is simple. This one and this one are equal to 1 over square root of 2, 1 over square root of 2, and this is 1. This is going to be one of very good tables for us to memorize. So I expect you to memorize this table within like 2 weeks. You're going to use these values a lot in future. So it's just better for you if you remember. And there are not too many numbers, right? There are a bunch of zeros, bunch of ones and negative ones. And if you count all other numbers, they are like square root of 3 or 1 over square root of 3, 1 over square root of 2, and 1/2 and square root of 3 over 2. So basically like 6 numbers to remember. Just you'll need to remember the pattern. Okay, let's take a little break. I'm going to stop my video. Okay, now I want to discuss situation. How do we calculate angle 6 functions for some other angles? So for example, for a unit circle. So what do we know so far? So far, we can calculate 6 functions here, 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 and here. We also can calculate some angles here, like over here and over here, right? And also pi over 4. But we don't know anything here, here, or here. For example, theta equals 3 pi over 4. How to calculate it? 3 pi over 4 is pi over 2 plus pi over 4. Okay, so the angle is going to be like pi over 2 up to here, and one more pi over 4. So it's going to be like this. This is my 3 pi over 4 angle. We know about this. Well, looks like symmetrical to this one. This one is pi over 4, and this one is 3 pi over 4. What's going to happen to x, y, and all these coordinates? Well, we see that if x coordinate here is 1 over square root of 2, here it's going to be negative 1 over square root of 2. If y coordinate over here is 1 over square root of 2, y coordinate over here is same. For this point, P has coordinates negative 1 over square root of 2 and 1 over square root of 2. Can we calculate sine, cosine, and tangent? Of course. We do remember that sine is equal to y, right? And y is 1 over square root of 2. Cosine is equal to x, negative 1 over square root of 2. And tangent, 3 pi over 4 equals to y over x, which is going to be what? 1 over square root of 2 divided over negative 1 over square root of 2, which is negative 1. So it's going to be the major way we calculate everything. Now, guys, I want you to try next angle on your own. You calculate yourself, 3 functions, sine, cosine, and tangent for 5 pi over 4. I'm going to count to 3. And ask you to kind of do the calculations, stop the video, and then check your calculations watching the video for solution. Okay, so 1, 2, 3. Stop the video, try to find the functions. And I'm going to provide solution. I'm hoping that you already got it. Solution. So what is 5 pi over 4? Well, I'm going to write down 5 pi over 4. That's actually 4 pi over 4 plus pi over 4, right? If you add them, I'm going to have 4 pi and 5 pi over 4, which is going to be pi plus pi over 4. Why I'm doing this? Normally, guys, if you do understand how the angle, where the angle is going to be, you don't need to do this. But just to explain a little bit more. So on my unit circle, this is my pi over 4, right? Now I have pi, which is this one, plus pi over 4. So it's going to be that angle over here. Remember that coordinates here are 1 over square root of 2, 1 over square root of 2. So here, we're going to have everything opposite. X is going to be negative and y is going to be negative. Well, because we have the same triangle here, right? So I'm going to write down the coordinates for this point. Well, we can write down the values. So sine of 5 pi over 4, that's y. Y is negative 1 over square root of 2. Cosine of 5 pi over 4 is x, which is negative 1 over square root of 2. And tangent of 5 pi over 4 is y over x, which is going to be like same, negative 1 over square root of 2 over negative 1 over square root of 2, which is 1. See? Okay. Well, so far we are dealing with pi over 4 angle. Let's try one more angle on your own. So my next problem for self-solving, and you stop the video, theta equals 2 pi over 3. And again, sine, cosine, and tangent. Sine, cosine, and tangent. Okay, and I'm going to count to 3 and show you a solution. And I want you to try to stop the video and do the solution yourself. So 1, 2, 3. Stop. And start. I'm going to draw the picture. I'll decide which part of my unit circle is going to work. So 2 pi over 3. Well, it looks like pi minus pi over 3, right? If I do this, it's going to give me 2 pi over 3. Pi is this. Pi over 3 is something like this. Pi over 3. So the point is over here. Here is actual pi over 3. Well, in my picture actually it's not pi over 3, but let's imagine. So what is the angle? The angle is this one, right? What is going to be symmetrical? What is going to be same? What is going to be different? First, recall that for pi over 3, the coordinates were, let me go back to the picture to show you. So where is my pi over 3? For pi over 3, which is 60 degrees, we're going to look at this circle. And you see the coordinates are 1/2 and square root of 3. I'm going to put them 1/2 and square root of 3 over 2, right? So what are going to be the coordinates here? Well, you see that y coordinate is same, so it's a square root of 3 over 2. X coordinate, which is 1/2 here, is going to be opposite over here, negative 1/2. Now we can write down the functions. So sine of 2 pi over 3, which is y, right? Y is equal to square root of 3 over 2, cosine of 2 pi over 3, x, negative 1/2, and tangent of 2 pi over 3, y over x, which is square root of 3 over 2, over negative 1/2. Here we have square root of 3 over 2 multiplied by 2 over 1, minus in front this one, and we have minus square root of 3. Well, that's how we calculate the other angles. Okay. Well, what else? What else we can have? We can have something more complicated than just well-known angles like pi over 4 and pi over 6 and pi over 3. We can have, for example, something like 15 degrees or pi over 12. So why don't you guys try on your own, use your calculator and figure out what is going to be cosine of pi over 12 and the sine of 15 degrees. Why do I use radians and degrees and sine and cosine? What I want you to do on your calculator, find out first how to turn between radians and degrees and how do you know which mode you are in, okay? Second, how to use to find trigonometric functions of the angles. I'm not going to give the answers over here in lecture, but I'm going to put them when I give you my notes so you can compare your answer. So here I'm going to put in parentheses, use calculator. Is it bad to use calculator in trigonometry? No, guys, most of the angles are not pi over 3 or pi over 6 or, well known. Most of the angles are something like 7.3450 degrees. And you will just need to use calculator. There are no other way to calculate, okay? So do not worry that you're supposed to use calculator here. Again, that's like an extra assignment. Calculate this using your calculator. Practice with it. How to calculate numbers for trigonometry, degrees, radians, and sine and cosine. Okay, they're basically same angle, by the way, pi over 12 and like 50 degrees. Now, last question left. What if the point is not on unit circle? You do know the point, but it's not on unit circle. Let me move this a little more further. Okay, what if P, something like this, not on unit circle? How do you know that's not on unit circle? Maybe it is on unit circle. Well, let's just square this and square this. You're going to get what? 4, a square of 2, and 25 as a square of 5, which is going to give you what? 29, which is definitely not 1 square. So it's not a unit circle. It's actually circle with radius equals a square root of 29. What should we do in this case? How do we calculate the functions? Well, we need a little explanation. How do we deal if points are not on unit circle? I'm going to start with drawing a triangle. And actually, I'm going to have 2 triangles, a big one and a little one. Imagine that this side is equal to 1, and the whole side, or whole hypotenuse, is equal to r, like a radius of a big circle, a radius of a small circle. Same angle here, theta. Imagine that on unit circle, the coordinates are y and x. And on non-unit circle, the coordinates are y, with a star, this one, and x with a star for this one, the whole side. You see that two triangles are similar. Triangles are similar. What does it mean? It means that ratio between the sides is supposed to be same. For example, if you take hypotenuse here and hypotenuse here and divide them, you are going to have the same ratio as the opposite side here and opposite side here. What does it mean? It means that if I divide x, which is a little tiny side of little tiny triangle, over x with a star, that's supposed to be equal to 1 hypotenuse of a small triangle over r, hypotenuse of a big triangle. From where I can easily find x. Well, my x actually is x with a star by 1 over r, which is x with a star over r. Have same for y. Y equals y with a star over r. Now, even if the point does not sit on unit circle, you can find corresponding coordinates on unit circle. So this is, imagine, this is not unit circle, and this is unit circle. So this is circle of radius r. This is circle of radius 1. So it's supposed to be sitting here, but now we can calculate all the functions. I'm going to turn the page. We have just a little bit more to finish. So what we have? Sine of theta, which is y in our case, and it's going to be y with a star over r. Cosine of theta, which is x, is going to be x with a star over r, and tangent of theta is going to be y over x, or y with a star over r, over x with a star over r. Interesting that for tangent, if we simplify everything, we're going to get exactly the same formula, just for starred values. What are starred values? Let's go back. Starred values are these ones. This is x with a star and y with a star. Well, let's calculate what we have. So our point was, I already forgot, it was 2 minus 5, right? The point was 2 minus 5. So we have sine of theta. What was the radius, by the way? Radius was square root of 29, very weird radius. Okay, sine was y, which is minus 5, over radius, square root of 21. Cosine is x, what is x? 2 over square root of 21, 9. And tangent is what? Well, basically y over x was a star, which is minus 2 over 5, 5 over 2. Okay, so self problem. Point P equals minus 3, 2. I want you to calculate sine, cosine, and tangent. And I'm going to count 2, 3. 1, 2, 3. Stop. And 1, 2, 3. Start. So, well, again, to use these formulas, I'll need to know r. So what is r? R, it's a square root of x squared plus y squared. I'm not going to put stars here, too many symbols, but you understand these are this x and y. In our case, it's minus 3 squared plus 2 squared, which is going to give us 9 plus 4, the square root of 13. Why do I use only positive square root? Well, because radius is length. Length is always positive. Okay. Now, I just use the formula. Sine of theta equals y with a star over r. My y is 2, my r is square root of 13. Cosine of theta equals x with a star over r, which is minus 3 over square root of 13. And tangent of theta, I even don't need the radius, I just need to divide y over x. Y over x. Negative 0 over 3. Okay. So that's all. Thank you. And do your homework. And I'm going to provide you with answers for 15 degrees. Okay? And I'm going to put online my notes too. So you can use notes to go over. By the way, suggestion, while you're watching the lecture, make your own notes. It's more helpful than watching my notes. Thank you, and see you next time.